Welcome back everyone. So far in this course we have learned what interpretability is, why it matters and how different models behave. Now we came to a topic that lies at the heart of real world machine learning design. This video is about the trade-off between interpretability and accuracy. This is not just a technical issue, it is a decision that affects trust, fairness, safety and responsibility. As we go through this video, I want you to think not like a student but like an AI designer or engineer or a scientist who must choose the right model, not just the most powerful one. When we build any machine learning system, we usually chase two goals. The first goal is accuracy. We want the model to predict correctly as often as possible. The second goal is interpretability. We want human to understand how and why the model makes its decision. In an ideal world, we would achieve both perfectly, but in reality, improving one often weakens the other. This conflict is what we call the interpretability accuracy trade-off. Let's talk about accuracy in more depth. Accuracy measures how well a model performs on unseen data. Higher accuracy usually means fewer mistakes. To achieve this, models often become more complex. They learn suitable patterns, interaction between features, and non-linear relationships. For example, a simple model may miss hidden trends in data, while a complex model can capture them. But as complexity increases, transparency decreases. So accuracy is powerful, but it comes with a. Now change our focuses to interpretability, which understand the decision, not just results. An interpretable model allows us to answer questions like why was this prediction made, which factors influenced the decision, does the decision make sense in the real world. Interpretability supports trust, accountability and ethical use of AI. Without it, humans are forced to blindly accept model outputs, even when those outputs may be wrong. This brings us to the core trade-off between interpretability and accuracy. Simple models like linear regression or small models like decision trees are easy to understand, but they may struggle with complex data. Complex models like deep neural networks can achieve excellent accuracy, but they behave like black box. So the question is not which model is better, the real question is which model is appropriate for the situation. In this image you can able to see when the interpretability is high, our accuracy may be low. If the accuracy is high, interpretability is low. This is how the system works. Let's consider a scenario in a healthcare. Okay. Imagine a model predicting whether a patient is at risk of heart disease. A highly accurate black box model flags a patient as high risk one. Now the doctor must decide, should I trust this prediction? Why is this patient is at risk? Which factor contributed most, like age, cholesterol or lifestyle? Which one is the factors affecting this decision? If the model cannot explain itself, the doctor may hesitate or was blindly trusted. In healthcare, interpretability is critical. Even a slightly less accurate but explainable model can be safer and more useful. Am I right? Now let's switch to image recognition. Suppose we are building a system to identify objects in images. Images contains thousands of pixels and complex spatial data patterns. Simple interpretable models cannot handle this complexity. Deep learning models perform extremely well, but they are black box. In such cases, accuracy becomes the priority. Interpretability is still important, but it is often addressed later using our explanation tools. Here, performance outweighs transparency. Now consider a loan approval system. A bank uses a model to decide whether to approve loan. This decision affects people's financial features. If a loan is rejected, the customer has the right to know why my loan was rejected. Regulations demand fairness and transparencies. Even if a black box model is slightly more accurate, banks often choose simpler explainable model. Here, interpretability is more important than marginal accuracy K. So, how do we choose the right balance? We must consider who is affected by the decision. What happens if the model is wrong? Can the decision be appealed? Is an explanation legally required? High risk human impact decision demand higher interpretability. Low risk technical task may prioritize accuracy. This is where explainable AI becomes more powerful. Explainable AI techniques helps explain black box model without changing their structure. They show features, contribution, decision patterns and local explanation. Explainable AI allows us to enjoy high accuracy while still improving transparency. It doesn't remove the trade-off, but it helps manages it. In practice, there is no one-size-fits-all solution. Responsible AI design means making thoughtful choices. Sometimes we choose simpler models. Sometimes we choose complex model with explanation layer. Often we include human in a decision loops. Good AI system supports human. They don't replace any judgments. Now we come to the end of this video. To summarize what we have learned so far, accuracy and interpretability both are essential. They often compete with each other. The best model is not the most accurate one, but the most appropriate one. You are agree with me, right? Understanding this trade-off is a key step toward building ethical, trustworthy and responsible AI system. In the next video, we will explore real-world case studies where these trade-offs played a crucial roles. Thank you all.